four members. They are me, Shereen,
Vienna.
Jesha.
Today we will discuss about
Simultaneous and
Proving.
Let's check it out!
Solving two simultaneous equations in this discussion. You will be provided two equations, then you have to substitute one subject equation to other.
So here is the example of simultaneous equation. The step 1 is we make x to the subject. So x minus 2y equal minus 4. And then to make this is subject, minus 2y move to the right. So x equals minus 4 plus 2y. So the equation is this. And then the step 2 is we make the x value to the equation. The equation is 2x plus 3y equals 12. So 2x plus 3y equals 12. And then the x is this. So 2x minus 4 plus 2y plus 3y equals 12. So just the step is we multiply 2 and minus 1 is minus 8 plus 2 multiplied by 2y is 4y and plus 3y equals 12. So we can simplify for y and 3y. This is 7y equals 12. So to make 7y the subject, we can put minus 8 to the right. So 7y equals 12 plus 8 equals 20. Y equals 20%. So the answer is 2.86. So we can search x by substitute this y value to this equation. The equation is x equal minus 4 plus 2y. And the y is 2.86. And the answer is 1.72. So we can prove this answer is correct. We can substitute this and this to this equation. So the x is 1.72 minus 2 multiplied by 2.86 equals minus 4. Minus 5.7 equals minus 4. So the answer is correct.
So, for deeper understanding, we provide you the next examples. So, here we've got two equations. Y equals 1 minus x and x squared plus y squared equals to 4. Because we already have the subject y here, we only have to substitute to the next equation. So, it will be x squared plus y squared, it will be inverted, 1 minus x and then squared equals to 4. And then we just have to solve it. X squared plus, it will be 1 minus 2x plus x squared equals to 4. Then we only have to simplify this. So it will be x squared plus x squared will be 2x squared minus 2x, and then this will be moved here, so 1 minus 4 equals to 0. 2x squared minus 2x, it will be minus 3, right? Equals to 0. After we got this equation, we substitute this into the ABC formula. So, minus 3 plus minus b squared minus 4 times A and C over 2A. So as we know, we've got the B here is minus 2, so it will like minus 1 times minus 2, that will be positive 2. Positive 2 plus minus, the B here is minus 2 squared minus 4 times, we've got 2 as A here, 2, and the C is minus 3 over 2 times 2 as A. And then the result will be 4 plus 24. Or we can just simplify this by roots of 28 over 4. So the rest of 28 will be 5.3 over 4. The next step is we have to solve this with positive and the other one with negative. 2 plus 5.3 over 4. This will be 1.83 as I round up at the calculator there. And then 2 minus 5.3 per 4 will be minus 0.83. We already got the x value here, 1.83 and minus 0.83. And then we have to substitute this value to find the y. As we know the y here, the equation is y equals to 1 minus x. So we only have to substitute here. Y equals to 1 minus the first x value, 1.83, which is minus 0.83, and then the next one is 1 minus 0.83. So it will become positive, and the answer will be 1.83. So we've got our final answers. It can be written also as, can I get? So we can write this also as when x equals to 1.83, the y will be 1. So we've got our final answer here.
And for deeper understanding, we got ourselves the third explanation here. Since in this equation, we already got the y, so we just need to substitute it to the other equation, like this. Then we continue by solving it. And since we already got this one, we're gonna simplify the entire thing by moving the 3 to the right and by simplifying both of this integer. And then we move the 10 to the right, making it into 1. We got the first answer here. We just need to substitute to the other equation, the y. We got the answer already by simply by solving both of these and simplifying it to the most simple form, which is 1 and also 1. So we got the answer, which is x equal 1 and y equal 1.
And for more deeper understanding, we provide you guys the fourth and last example of simultaneous equation. So, the first step is to substitute the first equation with the second equation. So the first equation right here we have y equals 3x plus 2, and the second equation is 2x plus y equals 8. So, how to do it is 2x plus, over here we have y equals 3x plus 2, so y is 3x plus 2 equals 8. So there you go. There you go. And now we have to simplify this equation. So 2x plus 3x equals 5x plus 2 equals 8. And now we have to find the value of x. But before that, we move this 2 to the right side. So 5x equals 8. Now since the number 2 is positive, when we move to the right side, it turns to minus. So minus 2. So 5x equals 6. And now x, the number 5, we move to the right. So 6 over 5. So x equals 1.2. Ta-da! We found the value of x. Now, we have to find the value of y. How you do that is, you write down the first equation, but you switch x with 1.2. So 3, 1.2 plus 2 equals 3 times 1.2 is 3.6 plus 2. So y equals 5.6. So there you go. We found the value of y. Okay, so the last step is to prove that both of these answers are correct. So how to prove it? You can use the question equation. So 2x is 1.2 plus y is 5.6 equals 8. 2 times 1.2 equals 2.4 plus 5.6 equals 8. 2.4 plus 5.6 equals 8. So it is proved that all of these answers are true, are correct.
Proof. In this proof, we will divide the material into 4, which are counterexample, consecutive integers, even and odd number proofs, and proofs using completing the squares.
Counterexample. Our goal is to prove that the given statement or equation is true or false by entering the integers as example. And moving on, we're going to explain about counterexample using this question. Is the sum of two perfect squares always a perfect square? We're going to use two perfect squares, which is we're going to use 2 and 3 in the power of 2, which is going to be 4 plus 9, which is equals to 13. But 13 is not a perfect square, but because there is no integer that can produce 13 if it's multiplied by itself. So, from this, we can say that this statement is not entirely wrong, and The actual answer is the sum of two perfect squares is not always a perfect square.
Consecutive integer. Our aim here is to prove about consecutive integers question. When n is an integer, consecutive integer can be written as n minus 1, n minus 2, and so on.
So the next is we tell you about consecutive integers. There are the example question of consecutive integers that prove that sum of three consecutive integers is always a multiple of 3. We can show you about first n integer by follow n plus 1, n plus 2. The second step is we sum this equation. So s plus n plus 1 plus n plus 2. And then we solve this equation. N plus n is 3n. N plus 1 plus 2 is 3. So we factorize this equation to 3 multiplied by n plus 1. So this is show we prove that sum of three consecutive integers is always a multiple of 3.
even and odd. Here, the key concept is even number is divisible by 2, so it can be written as 2n plus 2, and etc. Meanwhile, odd number is 1 more than even, so it can be written as 2n plus 1, 2n plus 3, and etc.
So I'm going to be using 3 and 1. So how to write it is 2n plus 3 squared minus 2n plus 1 squared. There you go. Okay, now we solve it. And plus 2. There. We multiply it. So 2n times 2n equals 4n squared plus 2n times 3, 6n, plus 6n, 3 times 3, plus 9, minus 2n times 1, 2n times 2n, 4n squared, plus 2n times 1, 2n, plus 2n, plus 1 times 1, 1. Okay, and then since there's a minus here, we have to multiply each of these numbers with the minus. Okay, so 4n squared plus 12n plus 9. 4n squared times minus, which makes minus 4n squared, minus 4n minus 1. There you go. And then 4n squared minus 4n squared, it means 0. 12n minus 4n equals 8n. 9 minus 1 equals plus 8. There. The final answer is 4 times 2n plus 2, which proves that the difference between the squares of two consecutive odd numbers is equal to 4 times the integer between them.
Completing square. Here, we prove quadratic function is more or less than 0 by writing it in perfect square form. To find the vertex or turning point, we can use guide minus b, minus c as x and y. And to find the y-intersect, let the x in the equation be 0. If a positive, the graph will be facing upwards, while if a negative, the graph will be facing downward.
So now we will discuss about proving with completing squares. So here I already provide one question but 3 branches. But don't worry, we will go one by one. So we've got A, B, C. We will dive into A first. Prove that 14x minus x squared minus 52 is less than 0 for any value of x. So actually, first we have to rewrite the equation first. 14x minus x squared minus 52 less than 0. And then we have to isolate the quadratic and linear equation by simply put brackets within them, okay, like this. And then we have to factorize minus. So we have to make minus outside this equation. So it will be minus in bracket x squared, and then minus 14x. Why minus 14x? Because minus times minus 14x, at the end it will be positive 14x. And then write the rest, minus 52 less than 0 here, okay? And then we have to make this quadratic equation into perfect square equation. By simply we have to factorize this. So we will end with x in bracket x, and then minus 14, and then we have to divide 14 with 2, which is, it will become 7. Don't forget to put square here. And then we have to solve it, which becomes, x squared minus 14x plus 46, right here. And then we put this back into our questions here. So it will be minus in bracket x squared minus 14x plus 49 here. And then we have to add minus 49 also here. Why? Because we want to keep the original value stay the same. Okay, so we add here minus 49, and then simply write the rest here. Okay, and then we put this back into the quadratic equation, perfect quadratic equation, or perfect square equation, sorry. So it will be x minus 7, here. And then don't forget the minus 49. 49 minus 52 less than 0. Okay, then we simply multiply this minus with this and minus 49. So it will be minus in bracket x minus 7 squared, and minus times minus will be positive. Positive 49 minus 52 less than 0. Okay, then we have to simplify this. So, okay, and then 49 minus 52 will be minus 3, right? Less than 0. So how do we prove that this equation is less than 0 for any value of x? We simply focus on this quadratic equation because it has the x here, right? And then we just simply, like, if you want to prove it, we just simply substitute any integer into the x, because any integer here will be squared and we will time with minus, so it will be less than 0, like certainly. For example, if you want to add, for example, minus 2 here, so the x will be minus 2, minus 7 squared. Okay, we then solve it. It will be 9 minus 9 squared. So this will be minus 9. It will be minus times 81, right? So it will be minus 81, which is less than 0. So we've got our final answer. I will write it here, okay? Because we don't have much space. So minus in bracket x minus 7 squared minus 3 will always less than 0. So here is our final answer for. Then let us move on into the B section, which is find the largest value of 14x minus x squared minus 52. So first we rewrite the given equation. So it's actually y equals to 14x minus x squared minus 52. But we already simplified this into this, right? It will be minus in bracket x minus 7 squared and then minus 3. So there's actually an equation or a formula that will make your life simpler. So this is the formula. So if you want to find the largest value of x and y, we have this formula, which is x, y right here. So x is actually minus b, and then y is actually the c. So you have to remember that in quadratic formula, this minus represent a, so the a is minus 1, and then the b is minus 7, and then the 3 and then minus 3 is c, okay? So from here we can clearly see that x that equals minus b, so it will be minus times minus 7, and the c here is minus 3, right? So we get the final answer 7 and minus 3. So our largest value for this equation for y is minus 3, and that's all. Okay, that's pretty easy, right? And then the last one, we got jump into C. Sketch the graph for y equals to 14x minus x squared minus 52. Okay, so here, actually here, is the turnover or the vertex that we will draw in the graph. So it will be like the top of the point or the final, not final, it will be the top of the point. Okay, and then because we already got the vertex, we have to find the y-intercept. How do we find it? It's actually pretty easy. You just have to follow. So y-intercept, we can get this by let. So we have to let x become 0. Okay, so we get y value at the end. So we rewrite the equation. Y equals to 14x minus x squared minus 52. Okay, here. Okay, and then we have to substitute the x into 0. So 14 times 0 minus 0 squared minus 52. So y equals to minus 52. So the y-intercept at the end will be 0 for the x, and then minus 42 at the y. Okay, and then we actually can determine also the shape of the graph. We will sketch later because here the a is already minus, so we can determine that our graph will look like this. Okay, it will like facing downward. So let's prove it. So here I already sketched the graph to make things easy and faster. So we already found our vertex or turning point, which is 7, minus 3. And then the y-intercept will be 0, minus 52, right? So we sketch the vertex first. 7 for the x, so it will be here, right? And then minus 3, because this already minus 10, this is minus 5, then around here. And then the y-intercept lies on x 0, 0x, and then minus 52 here. So here is minus 50, here is minus 55, so minus 52 is, I believe it will be around here, right? So we have to sketch. Okay. So this is what our graph will look like. I know this is not the best of the graph, but it is like the rough sketch will be like this, with the graph is turning down at the downward. And then this is our final. So that's all for today from Group Loping Math. We already learned about
Simultaneous, proving,
How do you guys understand our explanation?
sorry for all of our mistakes here, and bye bye. Have a good day.
Gimana sih? Yang cepat. Ya.